I gave you my love, I tell you what I do.
So this one is from 2 to infinity. They're mixing it up. Instead of a 1, we have a 2 now. And then dx over x to the third minus 4. And they tell us in the problem to compare with the following. 2 to infinity, 2x to the negative 3 dx. Okay, so this is the same thing as writing 2 as this, right? That's just a different way to write it. So just visually, we can compare. And let's see. So we're basically comparing these two. X third. Okay. So let's see if this is true, first of all, and make sure it's not the other way around. Like that 1 over x to the third minus 4 is greater than or equal to. So let's check. We can, first of all, like divide the 2 down, right? So if we divide by 2 on both sides, 1 over 2, just so we get equivalent numerators, right? So then we can actually compare. So we get 2x to the third minus 8 on the left, and over here we just get a 1 over x to the third. Okay, so now let's check that this holds true for our interval, which is 2 to infinity, right? So let's check it at 2. We get 1 over 2 times 2 to the third minus 8 is less than or equal to, we don't know about this, we're going to check it, 2 to the third. So this on the left is actually 1 over 8, and then on the right it's 1 over 8. So this is true because it says less than or equal to. So this is the equal to case. So we're good here. And then let me check another one. Let's try a number greater than 2. So let's try 3. So 1 over, here, I'll just do it in a separate section here. Okay, so 1 over 2 times 3 to the third minus 8, is that, we're asking, less than or equal to 3 to the third? And then as you can see, this will turn out to be 2 times 27 is 54 minus 8, 46, I believe. 1 over 46 is less than or equal to 1 over 27. Yes, it is. So we're good. So this holds true. So I'm going to write that down on the next one. So we verified that 1 over x to the third minus 4 is less than or equal to 2 over x to the third. Okay, so now, and this is like our f of x, right? Because that's the greater than one. And this is our g of x. This is the one that we're looking at, g of x. Okay, so now we have to look at what is the behavior of f of x. We actually want it to converge, but let's see if it actually does. So, we're going to evaluate. We have 2 over x to the third dx. And we just want to see, we don't necessarily need to evaluate it, but we're just going to see if it converges or not. So this, we can bring out the 2 just for convenience. And then we have 1 over x to the third dx. And then from here, this is the p integral test. So our interval is from 2 to infinity. So this is like a to infinity, right? And our p equals 3, which is greater than 1. So this does converge. Converges. Yay. So, according to the comparison test, or the squeeze theorem, or whatever you want to call it, sandwich theorem, however you like, then since f of x converges and is greater than or equal to g of x, then g of x, which equals 1 over x to the third minus 4, must also converge, right? So this must also converge. Okay, so yes, it does converge.
Oh, baby, there's so many good things I could say about you, girl. I could say that I